Hello, this is Jason Goss. I'm the unit manager of the Asphalt Testing Lab at Pennsylvania Department of Transportation. In this presentation, I will go over the main types of tests that are performed on the field samples, which are collected from the roadway construction projects. We operate under Bureau of Project Delivery, Construction and Materials Division, Laboratory Testing Section. Our lab is centrally located in Harrisburg with an area over 100,000 square feet. Besides the asphalt lab, there is aggregate and soils lab, cement and concrete lab, chemistry lab, physical and instrumentation lab. PennDOT delivers construction materials by using its in-house delivery system, known as Pony Express. Each district has one Pony Express truck that collects samples from projects and delivers them to our lab at least once a week. Our lab typically processes loose box samples or coarse samples as seen in this picture. Often, these two types of samples are related to each other, and the test results dictate the percentage of contractor payments for the specified construction item number. Samples are processed with TR-447 forms. Barcode labels that carry the TR-447 reference numbers are attached to the samples when they are sent to the lab. Here, you see an example of a TR-447 barcode on the sample. Here, you can see the inside of the loading dock. There's a desk with a computer. And here are the barcode readers. The most common issues we experience during arrival are related to the samples not being labeled. Here you can see some of the most common problems that are listed. These issues may lead to serious delays and may require amended reports, which should be avoided. From time to time, we receive emulsion or tack coat samples. It is important to note that they should be sent immediately, since the asphalt in emulsion and water tend to separate in long term. Also, there should be enough packing material to prevent or contain any potential leaks. A 1 liter or a 1 quart clean plastic container with a wide opening and a list must be used for tack or emulsion samples. Appropriate labeling and marking should be placed on the side of the container. Avoid using any other type of container, such as soda bottles, etc., as these bottles may contain other material and may affect the test results. After the samples are scanned at the loading dock, we move them to the sample setup room. Here, we sort them, assign lab numbers, prepare worksheets, and schedule the tests. Primarily, we follow the Pennsylvania test methods, also known as PTMs, which are derived from AASHTO and ASTM test methods. PTMs are listed in Publication 19, Field and Laboratory Testing Manual, which can be found on PennDOT's website at www.penndot.gov under Forms, Publication, and Maps. In the Asphalt Testing Lab, we mainly perform three types of tests, and those are aggregate extraction and gradation, PTM 702, solvent extraction method, or PTM 757 ignition oven method, and PTM 739 gradation. Second type of test we perform is the bulk specific gravity of cores, and those are PTM 715 and PTM 716. Finally, we perform AASHTO T209 test method to determine the theoretical maximum specific gravity of asphalt mixtures, which is also known as GMM. Let's talk about the ignition lab. In the ignition lab, we perform PTM 757, which is the determination of asphalt content and gradation of bituminous mixtures by the ignition method. The results of this test determine the pay factors of a construction item with the following breakdown. Asphalt content, 30%. Material that passes number 200 sieve, 10%. Primary control sieve, 10%. Primary control sieve is the sieve that defines the breakpoint between fine and coarse graded mixtures for each nominal maximum aggregate size. And this is how the procedure starts. First, we heat the samples so that we can mix them homogeneously. After mixing the samples in a tray, we split the sample into two portions and place them in these baskets that you see. Each of these numbers are related to one increment, which represents a sublot of 500 tons of material. We then place these samples in these ovens, which are preheated to 538 degrees Celsius or 1000 degrees Fahrenheit. We weigh the sample along each step of the process. First, we mix the sample and weigh it. Then, we weigh it again after burning it. This way, we can calculate the asphalt content because the binder burns. Then, we wash the sample, dry it, and weigh it again, which allows us to calculate the material that passes number 200 sieve. This is our washing station. And this is the oven we use to dry the aggregate. Once the aggregate is dry, we move it to the gradation lab to grade it. These are the equipment we use in the gradation lab. On left, you see the sieves stacked on top of each other. These sieves have different openings, and the finest sieve is called number 200 sieve, which is on the bottom. On right, you see the shakers. After placing the sample in the sieves, we shake them in these shakers for 7 minutes. After the shaking process, we weigh the material that's on each individual sieve and record their weights. This is what our worksheet looks like. On the right-hand side, we enter the weights during the ignition oven testing, and the technicians insert their initials on the left-hand side. On the bottom portion, we record the sieves. Let's take a closer look at this portion. The sieve size listed on this worksheet follow the same sequence of the sieves. The sieve with the largest opening is placed on top, and you have number 200 sieve on the bottom. The metric units are presented here in red. Number 200 sieve corresponds to 0.075 millimeter, and the largest sieve size we may use is typically 2 inches. We record the weights on this worksheet, and the percentages are calculated by eCAMMS once the data is entered in the system. Next, I'm going to talk about the density lab. As we all learned in school, density is the mass of an object divided by its volume. To understand the density that is referenced in Pub 408, we first need to understand what specific gravity is. Then we should understand what the theoretical maximum specific gravity is. Specific gravity of an object is the density of a material divided by the density of water. After this division, the units cancel out each other, and specific gravity becomes a unitless number. The reason for doing this is to create a global consistency, as different units of density may be used by different countries. So, what is theoretical maximum specific gravity? Asphalt mixtures are made of 3 components, and those are aggregate, asphalt binder, and air voids. Theoretical maximum specific gravity of an asphalt mixture refers to its specific gravity value with no air voids in it. In the lab, we are able to remove all the air from an asphalt mixture by using vacuum and calculate its theoretical maximum specific gravity. So, the theoretical maximum specific gravity of an asphalt mixture refers to its specific gravity value with no air voids in it. Therefore, when we talk about the density of asphalt mixtures, we refer to the ratio of specific gravity divided by its theoretical maximum specific gravity, which gives us a measure for compaction. The higher the percentage means, the more the pavement compacted. But we should keep in mind that air voids in the range of 4% to 7% should exist in asphalt pavements. Therefore, overcompaction may lead to rutting issues. We use PTM 715 and 716 to calculate density. PTM 716 is used when a sample contains open or interconnecting voids which then causes the sample to absorb more than 3% water. First, we cut the core sample in their desired thickness. Then, we soak the samples in water bath, where the temperature is kept at 77 degrees Fahrenheit. After soaking it, we use a damp towel to capture its surface dry saturated weight. This is the weight of the sample when its voids are filled with water. Then we use volumeters, and depending on the size, we select the one that's appropriate. We fill the volumeter with water, insert the sample, and capture its weight. Finally, we dry the sample in the oven or a drying unit and capture its dry weight. Once we capture all the weights, we calculate the bulk-specific gravity of the sample and the percentage of water absorbed by the sample. If the percentage of water that is absorbed is more than 3%, then we use PTM 716. In that case, we soak the sample in paraffin wax, which then stays in the air voids, and we proceed with calculating the bulk-specific gravity. Also to mention, we have SuperPave gyratory compactors in our lab. In 1993, SuperPave system introduced the SuperPave gyratory compactor, which is used to densify mixes in the lab for mix design purposes. Gyration levels and design are correlated to the 20-year design traffic easels. As seen in this table from ASH to R35, and design varies between 50 and 125 gyrations, depending on the roadway's 20-year anticipated easel. Further information on SuperPave gyratory compactors can be found in the links below. It should also be noted that SuperPave gyratory compactors are used for preparing performance test specimens for Hamburg Wheel Track Test and the AMPT. The rest of the presentation is designed for PennDOT inspectors who might be setting up asphalt samples in eCAMMS. It is important that these samples are set up in eCAMMS prior to sending them to the lab. Also, there's an effort to transition to paperless TR-447 forms by using Sample ID mobile application. That requires the samples to be set up promptly. In eCAMMS, there is a page called Sample General page, and it has fields that match the TR-447 form. All the information on TR-447 form is captured in the Sample Details section of the Sample General page. We can divide the TR-447 form in 3 sections as top, mid, and bottom sections. The first field is the material code. Generally, we use these 4 codes for the asphalt samples that we receive from the field. 02 is used for GMM samples, 11 is used for density, 97 is used for ignition oven samples, and 98 is used for solvent extraction samples. Once a sample is processed and tested, they are discarded. Therefore, it is important to enter the material codes correctly so that they are processed with the correct test method. Next field is the material class. This is where you select the material class in eCAMMS. Material classes are listed in Appendix A of Project Office Manual, POM, which is also POP2. This is what Appendix A of POM looks like. Starting with the item number, refer to the correct specification section of POP 408, then follow the material code, and finally find the correct material class. Next field is sample class. They are also listed on the reverse side of the TR-447 form. Generally, the contract acceptance samples are coded as AS, and GMM samples are coded as FV, meaning field verification samples. This is where the sample class is selected in eCAMMS. Here you see the list of sample classes. For ignition oven, solvent extraction, and density acceptance samples, the sample class AS should be selected. For GMM samples, sample class FV should be selected. Lot and batch number. Asphalt samples begin with lot number 1 and continue consecutively for each new lot. A typical lot size for asphalt sample is 2,500 tons, and a typical lot size for longitudinal joint sample is 12,500 lineal feet. Place collected. Here, provide the detail on where the sample is collected from. For example, I-81 northbound mile marker 125.1. Enter the date the sample was collected in this section. Here, enter the number of increments. Each increment refers to a sublot. There are generally 5 increments in a lot, but sometimes it may be minimum 3 or maximum 7, depending on the lot size. Enter the TR447 reference number of the related sample in this field. For example, if we're setting up this for an ignition oven sample, enter the related density sample's TR447 reference number here. In general, tank numbers are used for plant verification samples submitted by the asphalt producers. Enter the construction item number from eCAMMS in this field. This field is used when a producer submits a new product to get listed in Bulletin 15. Product name. This field is also related to the new products for Bulletin 15. Enter the eCAMMS contract number in this field. This is the WBS element that should be used for that sample. Supplier codes are listed in Bulletin 14, 41, 42, and Bulletin 15. POP 408 year, version, and section. In this section, enter the POP 408 year that the contract is under. Version is the change number of POP 408. There are 4 possible options for the section field. Prior to April 2020, asphalt payments were specified in Section 409. We can draw a line here to separate whether a project is under PWL or not. Depending on whether standard specifications or restricted performance specifications are to be used, the letters A or B are used along with PWL or without PWL. For projects that are led after April 10, 2020, the spec section changed to Section 413, and instead of using the letters A or B, STD is used for standard specifications, and RPS is used for restricted performance specifications. If the construction item of the sample is governed by a district special provision, enter the special provision's name here and check the checkbox. In that case, the payments won't be calculated automatically by eCAMMS, and the district office will calculate the payment manually. Middle section of the TR447 is designed for the personnel contact information. Provide the names, phone numbers, and email addresses of the individuals that are involved in the sampling process. The bottom section is designed for GMM samples. Make sure to provide the placement date of the sample and the theoretical maximum specific gravity value submitted by the contractor for that date and sample. Down below, provide the JMF year and number. For density samples, provide the lift thickness. Any other important information that are related to the sample should be indicated in the remarks section. Some examples for the remarks section can be density acceptance by optimum rolling pattern or non-movement, materials acceptance by certification, work stoppages, unique or special conditions. When you're setting up ignition oven samples, those are material code 97, make sure to add the related density samples. If the density acceptance is by optimum rolling pattern, indicate that in the remarks section in eCAMMS. After relating the density sample, check the Merge Reports checkbox. This way, eCAMMS will calculate the contractor payment promptly. While setting up GMM samples with material code 02, make sure to set it up as field verification sample. And after adding the related density sample, uncheck the merge reports checkbox. When setting up density samples, those are material code 11, add the related ignition oven sample or solvent extraction sample and check the merge reports checkbox. When you're done with the sample setup, you should see the associated GMM sample on the bottom. If your project is stopped due to weather or other unforeseen reasons, and if that stoppage is less than 5 days, continue with the original lot. If the stoppage is 5 days or more, then adjust the lot size and sublots according to Table D in Section 409. Do not check the Terminated Lot checkbox if your project experienced the stoppage. However, if the contractor stops the paving operation and if the contractor notifies the inspector in charge in writing of the lot termination, including the reason for termination, then check the Terminated Lot checkbox. If you end up with a partial lot, refer to Section 409.3H2A1 and check the partial lot when there are 1 or 2 increments that are present for a lot. When setting up longitudinal joint samples, make sure to create a sample group name and remember the lot size should be in lineal feet. If you have any questions, feel free to contact me. Thank you and have a wonderful day.